Hello folks, welcome to the Age of Asparagus and Phase 2 of making a 3D top-down shooter in Godot. The plan for Phase 2, which will probably be around 5 videos, is to create a tool for generating levels of various sizes with randomly placed obstacles and a seed so we can regenerate the levels we like. We'll add parameters for randomizing obstacle height and for changing the obstacle colors. We'll make sure the map connects by using a flood fill algorithm so that the obstacles don't cut off sections where enemies can get stuck. And finally, we'll create a way to save the levels that we like for use in our game. By the end of this video, we'll have a basic tool that will allow us to generate a level directly in the editor, and we'll be able to edit the map's width, depth, and the obstacle density from within the inspector. If you haven't been following along with the series so far, and you're only here for Phase 2, the level generation and learning how to make a tool in Godot, then you can find a link to the code on GitHub in the video's description. It should take you to the tags page of the game's repository. So to start this one, if you want the code where we're at, you should download the zip file for the end of episode 1.8, and then you can follow along. Okay, we're going to start by creating a new scene. It'll be a 3D scene. And let's rename this spatial map and save it Control S in our level folder. I'm going to create a new folder called LevelGenerator. And instead of saving this map.tscn, I'm going to save this LevelGenerator. Okay, so to start, we want to get the ground in there. So let's go back to our level. And under the navigation mesh instance, we're going to select our ground and right click it and save branch as scene. So we're going to create its own scene. We'll put it under the level generator. Ground.tscn is good. And after that, I'm just going to close the level. Sure. So I don't keep accidentally clicking back to it. We're not going to need it anymore for a bit. And now in our level generator, we should have a ground scene. But we're actually going to generate everything in code for our level generator. So in our map, let's add a new script. Level generator is fine, and it should be in our level generator folder. Let's add a reference to our ground scene. We're going to export a variable. We'll call it ground scene. And this is going to be a packed scene. So I'm using capital letters here for this variable, just because it's not instanced yet. So we're kind of dropping in a class, and then we're going to create a ground instance from that class. So let's go, if we click on the map here, we should have the ground scene. It's empty in the inspector, and we'll drag the ground onto it. It's not going to show up here because we haven't instantiated it yet. So in the ready method, I'm just going to call a generate map function, which we're going to create, and we'll put everything in there. So let's do a new function, generate map, and we'll start just with a sanity check that we are generating our map. And then we're going to add a child to our map node, add child, and it's going to be ground scene dot instance. That's a method, right? Yeah. Okay. And now we should see it when we run the scene. Remember, we don't want to play the main scene. We're just going to play our currently open scene with F6, and we don't have a camera, so let's add a camera. And we're going to hit 3 on the number pad, rotate this down. Right there, you could see it was 90 degrees. That's what we want. Now it's 0. And I'm going to move it up quite a bit. I might have to zoom out and move it up a little bit more, and let's see if we can see our ground now. Too zoomed in. Okay, I'm zooming out with scroll wheel, move that camera up a bit more. There we go, that's fine. Okay, back to map, script. Okay, it worked, right? We saw the ground appear. So the first thing we're gonna make manipulatable is the width and depth of the map. So let's add a couple more exported variables. These will be the map width, and I'll set those to 11, which I think is what it kind of is by default, and the map depth, also 11. And when we generate the map, we'll set the ground scene's width and height. So instead of instantiating the ground scene directly within the add child method, let's save it as a variable here. And we know our ground scene is a CSG box, so let's just give it that type hint. And here we can add the ground. But before we do that, let's set the ground's width equal to the map width, and we'll set the ground's depth to map width, map depth, depth. Yes. Good. Okay, so if we go to the map, let's make it a little smaller here. We'll make it 7 by 7, and we'll run it, and we should have a smaller, that's a little weird. That's not 7 wide, is it? Okay. Remember that our squares are actually 2 units wide each, so we're going to double the value that we give the inspector. So let's try that now. There we go, 7 by 7. So what we're going to do is we're going to only use odd values, and that's going to prevent us from getting half, since it's always generating from the map spatial here, which is in the center. We want an odd number 1, so we always have a center square for the player to spawn at the beginning of each level, and it'll prevent us from getting half tiles out here. So we can just show that here in the inspector. If I did, for example, 4, a width of 4, and we ran it, it's still growing from the center here, which causes us to get half tiles on the side. Okay, so as we add more variables for us to tweak our level generation and we start adding randomness, we don't want to have to run the scene every time to see our results, right? I want to see them live. I want to edit this number and watch it live in my 3D scene in the editor here. So this is where we're going to use a powerful line of code at the very top of our script, which is tool. So when we add this to the top of our script, it makes our code execute in the editor here. And it's probably worthwhile, if you're interested in this, after you've kind of gone through a bit of maybe this in the next few tutorials, that you go and read the documentation on tool, because it's pretty cool. But let's see if we can get it to run now. So one thing to note is this ready method. It runs when you open the scene, and it may run when you save it. It does not run when you save it. So this ready method is going to run, let's close level editor, and let's reopen the level editor. And there we go, look, bleep bloop generating map. So it actually ran this code when we open the editor, and if we go to the 3D scene, we should see here that it actually did create our ground. And if we go back to our 3D scene, let's see if we can edit the size. So that's not working right now, because when we change the size, we never actually tell it to regenerate the map again. So we're going to do that by using setget. So this is going to allow us to define setters and getters, methods for when we want to change the value of map width. So setget followed by the name of our setter function. So let's just say set width. And then if you wanted to, you could follow it by a getter function, get width, but we're not going to bother with that part. So setget set depth. And now we're going to have to define those functions. Let's do it after our ready method. So function set width. And we have to give it one parameter, which will be the new value. And I'm just going to say new value so I can reuse that, kind of copy paste this code a bit. So we're going to set our map width to the new value. And we're going to do the same thing for the depth. Change this to set depth. And we'll change that to map depth. So right now, nothing has changed. We've just defined what by default was going to happen anyway, which is when you change the value of the width and height in the inspector, it changes the value of our map width variable. The difference here is now we can run additional code when we change it, and we want to generate the map. And we'll do that when we set the depth to. This is where the magic happens. Okay, now if we go back to our 3D scene and we change the value, it should regenerate the map, which actually it's doing. It's just creating more and more grounds which you can't see because I think they're probably all overlapping. So if we maybe if we made it bigger, there you go, you can see the new ones just being added more and more and more. There's a whole bunch there. Okay, so what we need to do now is every time we generate a map, we want to delete everything that was already there and completely generate a new one from scratch, so we don't get all that happening. So let's do that right at the start after we bleep bloop. And we can do that with a for loop. So we're going to go for node in get children. Let's get everything, all the children. And we're just going to queue free them. Now you got to be careful when you're queue freeing things in ToolScript. If that comes up, I'll let you know. That should be in a dot queue free. Okay. And let's see if that works. Okay, map. Oh, that's so cool. I like it. I'm getting distracted by this grid, so I'm going to go to the view and I'm going to turn off the view grid. Yeah, that's neat. And I'm also going to hit 7 to go into top view, because this is kind of how we're going to look at it. Okay, so you can see why we only want odd numbers. Odd numbers are going to give us some nice maps. That's kind of fun. Okay, let's carry on. So let's do a little more work on our map width and depth to give us useful values. One thing we can do is we can provide a little more information to the inspector about what values we want to be available for our exported variables. So after the export, almost like this is acting like a method, we could give it a few parameters. And one thing we can tell it is we want it to be an integer. That's actually the first thing you got to tell it, is the data type you want to use. Now, it's actually inferring this from the fact that we gave it an 11. And if I remove that and just have it on depth, you can probably see here, it is limiting it to integers. It's just inferring the data type from the value, the initial value we give it. But we're going to give it a bit more information. And one thing we can do is we can give it a low value and a high value, a minimum and a maximum. And for now, let's give it a minimum value of 1 and a maximum value of 19. And we can do the same for the depth as well. And now you should see I can't go above 19. And if I click in the area and drag back and forth, it'll go from 1 to 19. I'll link to the docs on exporting, and it'll tell you kind of all the other stuff and ways you can use different parameters you can give the export. But we also want it to only be odd, which it's not doing right now, and there isn't really an elegant way to do that, it seems. So instead what we're going to do is in our setter and getter, we're going to take the new value and we're just going to force it to an odd number. So let's create a new method, and let's call it makeOdd. And we're going to give it two things. We're going to give it the new integer, and we're also going to tell it the old integer. Because if we're making something odd, we need to know whether we want to round it up or down. And so what we'll do is we'll just, if the number is going up, then we'll round it up. And if the number is going down, we'll round it down. Otherwise, we'll end up with some weird issues where, for example, if the number was 17 and we tried to move it up to 18, it would just keep going back down to 17 again. And we just get stuck on one number, which I discovered by writing this little thing. Okay, so we need to know if it's odd or even. So we're just going to check if the new int, we'll take the modulus with 2. And of course, if it's even, it'll have no remainder, right? It's even. So we're going to have to do some stuff. Let's just say make it odd. Good. And otherwise, it's already odd. So we'll just return it. So, okay, let's make it odd. How are we going to do that? Well, first, let's check if the new int is greater than the old int. So if it's greater than, then we're trying to increase the number. So let's round it up. We're not even really rounding it up. We're just adding 1 because our new integer is even, and so we're going to bump it up by 1 to make it odd. And if it happens that our new integer is less than, then we're going to return our new integer -1. Think that'll work? We don't have any errors. We have a method. Let's try and use it now. So instead of setting it to the new val, we'll set it to, let's make it odd. And we need to give it the new value and the old value. And the old value, of course, is the current map width. Right? Do the same thing to the depth, except the old value would be the map depth. And if we go to the 3D view now, hey, look at that. It's forcing it to an odd number. That's cool. And it looks like 19 is probably too high, right? At least in this view. So why don't we, I'm going to zoom out a little bit, and we'll go, let's go 15 depth and maybe 21 high. So we'll go back to the script, and we'll set the max depth as 15 and the max width as 21. So we kind of have a rectangular, where are we go? There we go. Yeah. Okay, let's add some obstacles. We're going to add some obstacles just in some random locations. So let's get that pack scene. We'll call it the obstacle scene as a packed scene. And we should probably save one of those obstacles. So let's go back to our level again. Where's our level scene? There's our level scene. Let's make sure we get one of the square boxes. We just want a square, okay? So if you got some of these other shapes, we just want this one. And we're gonna save branch as scene. We'll say, make sure it's in your level generator, same place as your ground. Instead of calling it CSG box, we'll call it obstacle. Good, and let's take that obstacle. I'm gonna close the level. And let's take that obstacle and we'll drag it over to the obstacle scene. Back in our map script, let's go instantiate some obstacles. One thing I'd like to do is, before we do this, because this generate map method is going to start to get really big, so instead what I'd like to do is I'd like to take all the parts of generating a map and put them in their own functions. So generate map will be simple. It'll just be calling a bunch of other functions, which should be really easy to read. So first, let's move everything where we clear the level. Let's call it clear map here, and which for now is just this. I don't know if we'll ever need anything more than that. And we'll call it clear map. And then let's add another method, add ground. And let's grab all this, put it in add ground. Good. No errors. And I'm just going to check out our 3D, make sure we didn't wreck anything. Good. No errors. And now let's add obstacles. Obstacles. Good. So we'll create one more method. Here. Wow, are we going to add obstacles? Where are we going to add them? What are we going to do? So if we're going to add them kind of randomly, let's add a new export at the top, a new parameter for us to fiddle with. And this is going to be a float. And we're going to say go from 0 to 1. So 0 would be like 0% obstacles, 1 can be 100% obstacles. And another parameter we can give is the increments. And I'm going to increment them in 0.05 increments in the inspector. And I'll show you how that works in a moment. So let's call this obstacle ratio. And I don't know, default it to 20%, say 0.2. And just like the others, we're going to set get, create a setter for this, set obstacle ratio. For the same reason, because when we change the obstacle ratio, we want to regenerate the map with that new ratio. So it's just going to be obstacle ratio, well, no, autocomplete. Oh, missing that. And we'll generate the map again. Okay. Do I have an error? Or is it gone? Indented block expected after declaration. Add obstacles function. I think I fixed that. Didn't I? 55-1? Oh, down here. We didn't do anything. Okay, let's just put pass there for now. Good. Okay. So if we go to the map here, you can see this is a float, so it kind of gives us a different widget. And if I drag, it's going to increment by 0.5. I can either click and drag that, or I can just click in the area and drag it, and we can go from 0 to 1, right? So, And now what we want to do is we just want to, sorry, let's go back to the 3D map. We just want to cycle through every row and every column and basically just roll a random number. And if it's less than 0.2, then add an obstacle. And if it's more than 0.2, we won't. So for example, at 1, our random number between 0 and 1 will always be less than 1. So we'll always add an obstacle. This thing would be full of obstacles. And if it was 0, our random number will always be greater than 0. So we'll never add an obstacle, right? That's, sorry. I'm explaining the obvious here. So we're going to do a double for loop with, we'll use x. So for x in range map depth. And then for, you know what, we're going to use z because we're in 3D, and y is vertical, right? So this is x and blue is z. So we're going to use, we will use z here. Sorry for the confusion. If you feel like using y, go ahead. 2D, it feels like you should use y since we're kind of 2D. Map depth. But if we ever start adding height, that would be our y. Wait, I used depth twice there. This should be width. So this is basically going to cycle through, right? And then it's going to go to the next line. Of course, I might be doing it backwards. It's going to be doing the depth first. So it'll actually be going and then it'll go to the next one, with x equals 1, x equals 2, x equals 3, 4. That one's x equals 0. Okay. So what we'll do is we'll pick a random number, and we can do that with randf. So randf here. If I go into the help search, it returns a random floating point value between 0 and 1. Perfect. Exactly what we want. Where are we going? LevelGenerator script. So if our random number is less than our obstacle ratio, then we'll create an obstacle there at this xz coordinate. So we're going to need a vector 3 that has the position of where our obstacles should be instantiated to. So let's call this obstacle position. And it's going to be a vector 3. And it's going to be the x value, the y value, well, let's start with 0, and the z value. Now remember, our units are doubled because our squares are 2 units wide each. So we're actually going to scale everything by 2 here. And let's go var new obstacle. So we'll instantiate the obstacle and we'll save it into a variable. And our new obstacle is going to be a CSG box again. Equals our obstacle scene dot instance. Great. Let's set the new obstacle's position. We'll set its transform dot origin. So in global space, we're going to set it to the obstacle position, which is this vector 3 we created, right? And that vector 3 is just starting at one point on the grid, and then there and there and there. Oops, sorry, there, and eventually it'll instantiate an object there. That's the plan anyway. This isn't going to work exactly how we want yet, but let's try it. Okay, so 3D. Is it going to work? Doesn't do anything. We never actually add it. We never add child. This time? Oh, yay, that's cool, it worked. Look at that. So 0, 0, of course, by default is going to be at the origin, and then it's going like z equals 1, z equals 2, z equals 3, z equals 4. Doubled, of course, because our units are doubled. So what we need to do is we need to offset that. So we're going to translate the origin by the width and depth of our map. Let's try that. So after we have the obstacle position, we don't need that. After we'll go obstacle position, and we're just going to add a new vector 3 to our original. So if it's in 0, 0, we're going to add this vector right here. Exactly. And for example, if it was this one, we're going to add the same vector, which will go there. That one would go there. That one would go to that corner. And then this far one should go to that corner. Okay, so that vector is just going to be half our depth and half our width. So let's go minus map width. We're subtracting because we're moving left on the X. And now I said we wanted half, but at the same time, our squares are 2 units wide. So that'll actually cancel out, and we're just going to use map width. And we don't want to change it all on the Y direction. And as well, we're going to subtract the map depth because the Z is going, positive Z is going down. You can see from 3D here, positive Z is going down, so negative Z means we want to subtract in the Z direction. So map depth. All right, how about now? All right, it looks good, except we are, it seems like we're offset by 1 in both directions. So let's shimmy that over by 1. Add all my nice little spaces here. Oh, it didn't. We have to get it to regenerate there. Oh, it didn't do it because I didn't save the script. There we go. Control S. Hey, look at that! So we can change the obstacle ratio. No obstacles. Full obstacles. Whoop, whoop, whoop. Awesome. We're making maps. And oh, look at that. We probably want to raise our obstacles up by 1 unit in the Y direction. So let's go, when we create our initial obstacle position, let's place that at 1. Yeah, it's not bad, eh? Cool. All right, that's probably good enough for our first one. Hope you enjoyed the show.